Hi everyone! Today we will create a very simple car game with Pygame. Now this tutorial is perfect for beginners because I will personally make sure you understand all the commands we type as well as the logic behind them. So on today's menu we will learn how to draw graphics, how to work with images, animations as well as relative coordinates, which is where the size of the graphics or the elements adjust to the size of the window. Now, in addition, I wanted to quickly mention that the new version of Pygame works perfectly with newer versions of Python. So we no longer need to downgrade anything, and just for example, in this tutorial I'm using Python 3.9. And lastly, I have a special thank you to Anvil for sponsoring this tutorial, and we will talk about them more towards the end of the video. So without any further ado, let's start coding. And we will of course begin with the imports. So we will first import Pygame, and then from pygame.locals we will import all. Now first things first, we will need to initialize our Pygame application with pygame.init and then an empty set of round brackets. Now once we do that, we also need to find a way of collapsing the application window as soon as we are done using it. That's why our last command would be pygame.quit. Now, if we try to run this code at this point of time, nothing will happen because before we even have a chance to interact with our application, we are closing it. So we are still missing a bit of logic in between these commands. So let's do the following. Let's create a new variable called running, and we will set it to true. Then we will add an event listener which waits for the user to click on the exit button. And only after the user clicks on the exit button, we can safely collapse the application. Now in Pygame, we do this with a while loop. So while running, we will then iterate over all the events of our application with a for loop. So for event in pygame.event.get and an empty set of round brackets, where all the events of our application are stored inside the pygame.event module, and we are then fetching them with the get method. But we're not really interested in all the events. We are only looking for the quit event, so we will need to be a bit more specific. So if event.type equals quit in all caps, then we will set running to false, which will collapse our while loop because running is no longer true, and our program will move to the next command in the sequence, which will collapse the window. Cool. Now to make it work, we will also need to set a window size. So right below our running definition, we will type pygame.display.set_mode, and we will pass a tuple into this method where the first argument represents the width, so 800 pixels for the width and 800 pixels for the height. We can then assign it to screen. We can save this file, and we can go ahead and run it. So we will open our terminal. Now in my case, I'm using Anaconda, but if you're not sure how, I have a really nice tutorial which will get you up to speed. Check it out. Cool. So once we are inside our working environment, we will copy the path of our project folder, and we will paste it inside our terminal following a cd command, change directory. Once we are in the correct folder, we will run our application with Python, and then the name of the Python file, which in my case is cargame.py. There you go. If I open my folder, you can see that this is the car game file. Cool. Now let's run it. Let's hit enter. And here's our blank application. There's really nothing going on. But the key note here is only after we press on the exit button, our application collapses. Awesome. Now let's set a background color. So right below our screen definition, we will type screen.fill, to which we will pass an RGB color. Now in my case, I'm going to go for an intensity of 60 on the red channel, 220 on the green, and 0 on the blue. And as you may guess, this will result in a mostly green color. Now if you guys are not sure how to work with colors, I have a really nice tutorial which you'll find very helpful. So definitely have a look. Now in order to apply some changes on our screen, we will need an additional command. So right below our fill command, we will type pygame.display.update and then an empty set of round brackets. And only after this command, our screen will actually turn green. But if we're already here, I'm actually going to set the title of my window as well. So right above our fill command, we will type dot display dot set underscore caption. And in my case, I'm going to call it Maria's car game. I don't know if it really matters. Let's save everything and let's give it a run. So inside our terminal, we will simply press on the up arrow, which will repeat our last command, and let's press enter. And there you go! Our window is now green and we have a title to this window. Perfect. Let's move on. Next, we will draw some graphics on our screen. And the best way to do so is by using relative coordinates. So for example, instead of specifying 400 pixels, we will specify the width of the window divided by 2. So yeah, in both cases, the results will look exactly the same. But what if we choose to change the size of the window sometimes along the way? We don't really want it to mess up our graphics, so relative coordinates are always better. So let's slightly adjust our code to make it all work. So at the very top, we will create a new variable called size, and we will assign it to a tuple of 800 pixels by 800 pixels. Now, in addition, I would also like to unpack this tuple into width and height. That's why we will type size equals width, comma height equals 800 by 800, which is probably a big no-no in many other programming languages, but in Python, it works like a charm. So then right below, instead of hard coding our tuple and passing it into a set mode, we will pass size. And now we can move on with drawing our road. Now the first step I'd like to do is I would like to select a width to our road. So we will create an additional variable called road underscore W as in road width. Now, in my case, I'm going to go for a size of 500 pixels, which is given to us by width divided by 1.6. Now, since we are dividing here, it also makes sense to convert this expression into an integer. That way, we are not getting a floating point number for sure. And once we have selected the width, we can then go ahead and draw our road. Now, we will simply do this by drawing a dark gray rectangle with pygame.draw.rect, to which we will pass the screen, following the color, which in my case is 50, 50, 50. And lastly, we specify the coordinates in a tuple. Now, the first value is the x value, or the horizontal coordinate from which we start drawing our rectangle. Now, let's set it first at width divided by 2, which is the center of our screen, and we can then adjust it further. Now, the next coordinate is the y coordinate, which is the vertical coordinate from where we start drawing the shape. Now, I would like to draw it from the very top up until the very bottom, so I'll just specify 0. Next is the total width of the shape, which we already decided. It's given to us by road underscore W. And then lastly, we would like to specify the total height of the shape. And since we'd like it to end at the bottom of our screen, we will specify height. But there's just one problem with this code. Our road is not exactly centered on our screen. So in order to center it, we will simply reduce road width divided by 2 from our x coordinate. And now if we save everything and we rerun our code, there you go. We have centered the road on the screen and we can move on with the road marking. And we will begin with a yellow mark, which is usually found at the center of the road. So first things first, let's select a road mark width. And in my case, I'm going to go for 10 pixels. So width divided by 80, converted into an integer. Cool. Now let's draw this rectangle. So right below our road rectangle, we will draw an additional one with pygame.draw.rect, where the first argument is the screen. The second argument is the color, which in my case is going to be a mix of 255, 240, and 60. It's a nice yellow, not too bright. And then lastly, we will specify the coordinates. Now, since we are drawing this line at the center, we will once again go for width divided by 2 minus road mark width divided by 2. Next, we specify the y coordinate, which is once again 0. We'd like to draw it from the very top to the very bottom. Next is the width, which we already took care of with road mark width. And lastly, we specify the height because we'd like that our line will span across the entire screen. Okay? Cool, now this takes care of the center mark. But how about the 2 white marks at the edge of the road? Let's go ahead and copy this command and slightly adjust it. Cool, so first things first, we will adjust the color. We will need those lines to be white. So 255 by 255 by 255. Next, we would like to adjust the x coordinates. So first we will select the edge of the road with width divided by 2 minus road width divided by 2. And since we don't want to draw it at the very edge of the road, we would like to have a few pixels in between. We will also add road mark width times 2, which will draw our line 20 pixels away from the edge of the road. Cool, so this is the first line. Let's go ahead and copy it to get the second line. Now we'd like this line to be applied on the other edge of the road, so we will simply replace all the minuses with pluses and all the pluses with minuses. And this should do the trick. This will give us this mirror effect. Let's save everything and let's have a look. Cool, so it's almost perfect. I slightly messed up with the second road marking, so let's quickly fix it before we move on. I think I need to multiply it by 3 instead of by 2, so let's quickly fix it. And I believe it will work. Yep. There you go. Here's our beautiful road with all the markings, and we are done with the graphics. Now let's go ahead and move on with placing some images, as in vehicles, on our screen. And because we've used relative coordinates rather than absolute coordinates, now we can go ahead and change the width of the window to 1200 pixels. We can save everything and we can rerun our code. The proportion between our elements remains the same. Yeah, the elements are slightly wider, but the ratio and their placement on the page is still beautiful. And same goes if we choose 400 pixels of width. Let's rerun the code. And there you go. We are still dealing with the exact same road, just a much smaller window. Okay, now let's place some vehicles on the road. Now in my case, I'm working with 2 different images. One is our vehicle and the other is the enemy vehicle. Now both of these images are saved in the exact same folder as our Python file. And you can either use my images, you can download them from GitHub, or you can design your own images, which I highly recommend. So back in our code, we will load the first image right above our while loop. And the reason why is because we only want to load it once. We don't want to load it time and again as our application runs and waste a lot of resources. That's why right above we will type pygame.image.load, to which we will pass our first image, which is car.png. Now we can assign this expression to car. And in addition, we will need to specify a location for this car image. And Pygame has a special way of doing so. So we will first need to fetch the location of this image with car.get_rect and then an empty set of round brackets. We will then assign it to car_loc, as in car location. And only now we can specify this location with car_loc.center, which, as you may guess, represents the center of the image. Now, in my case, I'd like to place it at the right lane in terms of width. Now, if you guys are living in London or Australia, definitely place it at the left lane, but I live in Canada, so I'm going to place it at the right one, which is given to us by width divided by 2 plus road width divided by 4. And then lastly, in terms of height, I'd like to place it at the bottom of our screen. So let's go for height times 0.8, which is 20% above the bottom of our window. Cool. Now let's go ahead and draw this image, because now we have just placed it and we loaded it, but we are missing the draw command. So below, right at the bottom of our while loop, we will type screen.blit, which represents an operation on bitmap images. So you can just imagine it as a draw operation, where the first argument is the image given by car, and the second argument is the location of the image given by car_loc. Cool. Now, since we are adding new graphics to the screen, we will also need to update our display. So we will navigate to our display update command, we will copy it, and we will paste it below our screen.blit command. Okay, let's save everything and let's give it a run. And boom, our first vehicle was successfully placed on the screen, and now we can move on with the second one. To save some time, we will copy the loading commands of our first image and we will slightly adjust them, where car becomes car2 and car.png becomes other car.png. Then car lock becomes car2 lock. And we will also slightly adjust the coordinates. So instead of placing our enemy vehicle at the right lane, we will place it at the left lane by switching from plus to minus. And then lastly, instead of placing our vehicle at the bottom of the screen, we will place it at the top of the screen, so 0.8 turns to 0.2. And then lastly, we will scroll below, we will copy our screen.blit command, to which we will pass car2 and car2 lock. Let's save everything and let's give it a run. And beautiful! Both vehicles are on the screen, and now we can focus on logic and animation. And first, let's tackle the logic. So if the user presses on the left arrow key or on the A key, we would like to move our vehicle to the left lane. Now, in order to do this, we will need to add another event listener. So below our quit event, we will add if event.type equals key down. Now, this will select all the keys of our keyboard, while we are actually only interested in the left arrow key or the A key. That's why we will add another conditional statement of if event.key equals, or actually, if event.key is in a list with k underscore A representing the A key and k underscore left representing the left key. And only if one of those keys were pressed, we will then move the location of our vehicle. So car underscore lock equals car underscore lock dot move, to which we will pass a list where the first argument represents the x coordinate by which we are moving the vehicle. So in my case, we're reducing half of the road width. So road width divided by 2. And if we're already here, let's convert it into an integer. And then the second argument represents the y coordinate by which we move the vehicle. So in our case, that's 0 because we are only moving right and left. Cool. Now let's copy these two lines of code and we will adjust them for the right arrow key as well. We'll just fix the indentation. So wherever you see k underscore A, it changes to k underscore D, and k underscore left changes to k underscore right. And then instead of reducing half of the road width, we will simply add half of the road width, and there you go. But a funny thing happens if we try to run this code. So let's go ahead and do that. I'll quickly demonstrate you what's wrong, and then we will fix it. So if we press the left arrow now, we're not exactly moving the vehicle, we are replicating it. Okay, so let's go back to our code. And the way to fix it is to copy all our graphics starting from the road down to the road markings. And instead of drawing them outside of the while loop, we will draw them in the end of the while loop before our blit commands. So let's paste it here. Let's fix the indentation. All right, let's save everything. And now if we press on the left arrow, we move to the left. If we press on the right arrow, we move to the right. Same goes with A and same goes with D. Now we will of course need to add some restrictions to those movements. It is not perfect, but we will talk about it in a different tutorial. You can of course do it on your end. I'm sure you can figure it out. But for now, let's animate the enemy vehicle. To do this, we will first select the location of the enemy vehicle at the very top of our game loop. So we will type car2 underscore lock, which we have defined above. Now, since we'd like this vehicle to go from the top of the screen to the bottom of the screen and beyond, we will only tackle the y coordinate, which is the second part of our tuple. Now we will select it by specifying the index of 1 after car2 location, where the index of 0 returns the x coordinate instead. Now, after we selected the y coordinate, we will simply add a plus equals 1 after it, and that's it. If we save our code, the first time we run through the while loop, the enemy vehicle will go 1 pixel below. The second time we run through the while loop, it's going to go another pixel below, and so on until it disappears completely. Now let's run this code. Let's double check if it worked. Oh, okay, I missed it. Let's do it again. I'll try to catch the screen while I do that. Okay, I caught it. Now, once I release it, the vehicle will keep going down. There you go, it worked. But now I would also like this vehicle to reappear at a certain point of time. Otherwise, we are playing all by ourselves, which is not exactly what I'm aiming for. And we can easily solve it with a conditional statement. So if car2 location in the index of 1, so if the y value of our enemy vehicle is greater than the height of the screen, we will then change car2 location in the index of 1 to minus 200, which is not exactly on the screen, but because this vehicle moves so fast, it's gonna look just fine. Let's save everything and let's rerun it. And awesome. Now I don't need to worry about catching the screen because the vehicle just keeps reappearing time and again. Now, let's do something even more challenging. Let's make sure that this vehicle appears on both lanes randomly and not just on the left lane. But before we do so, let's make sure our code is readable. So we will create special variables for the left lane and for the right lane locations. So let's go ahead and copy the right lane command and we will scroll above where we will create a right_lane variable and we will paste the command we just copied. Then right below, we will create the left_lane, which is the exact opposite. So we will replace the plus with a minus. Cool. Now let's use these variables. So let's scroll below. The X location of our vehicle, of the user vehicle, will now become right lane. And the X location of the enemy vehicle will now become left lane. Cool. Now, since we would like to work with randomness, we will also need to import the random module. So at the top of our code, we will import random. Awesome. Now let's use it. So let's scroll to our game loop where we will slightly edit our conditional statement. So if random.rand int, as in random integer, and in my case, I'd like to choose from two different integers between 1 and 0. So we'll just pass 0 and 1. And if the random integer turns out to be 0, we would like to do the following. So we would like to adjust car2_lock.center, and we will adjust it to right lane in terms of the x coordinate, as well as minus 200 in terms of the y coordinate. We're just keeping it consistent to the above line of code. But if the result is not 0, if the result is 1, we will then like to copy this line of code, and instead of drawing it at the right lane, we will draw it at the left lane. And since we are specifying minus 200 in both cases, we don't really need this line of code from above, so let's just get rid of it. Cool. Let's see if it worked. And awesome! Now we are randomly selecting the lane in which we draw the enemy vehicle, which is almost perfect. The only thing left to do is to take care of the endgame logic, which is what prevents us from colliding with the enemy vehicle time and again, and that's the most important part of our application. So let's take care of that. So right above our event listeners, we will add the endgame condition, which is if car location in the index of 0 is equal to car2 location in the index of 0, which means that both vehicles are on the exact same lane, but we will also need to evaluate their height because that's not enough. So we will add and car2_lock in the index of 1, which now represents the height. And if this height is greater than car_lock in the index of 1, and actually, that's not a very good condition because if you guys remember, we are working with the centers of the image rather than the edges of the images. So if we leave this condition as is, our vehicles will only crash when they are leveled. While in real life, vehicles crash when they kiss, okay? So let's reduce 250 pixels from this condition. And now it should work because my vehicles are 250 pixels all the way around. That's the image size. Now, if this condition is met, our game will end. So we will first print game over, you lost. And then right below, we will also need to break this while loop, which will get us to the very last line of code, which will collapse our window. Okay? Let's save everything and let's give it a test. Very excited to start playing. Move! Awesome. Move! Move! Okay, and once the vehicles kiss, the application crashes and the game is over. We lost. Now, we can of course keep playing this game as is, so we'll just move from right to left, from left to right, and everything is rainbows and butterflies. But the only problem is, at a certain point of time, this game might become a bit boring, because we're not exactly increasing the difficulty and there's not much progress throughout the application. So how about this solution? What if we increase the speed of the enemy vehicle as the game progresses? So at the very beginning, we will deal with a relatively slow enemy, which is quite easy to beat. But as time goes by, the speed of the enemy will increase, and therefore it will be much more difficult to beat it. But before I show you how to do this, allow me to quickly introduce you to Anvil, our lovely sponsors for this video. Anvil has everything you need to develop and deploy a web application with nothing but Python, and it's free to try. Create your user interface by dragging and dropping components or writing Python code. No JavaScript, no CSS or HTML required. Anvil's web-based editor allows you to develop in your browser, so there is no need to install anything. You can use Anvil's built-in database and let Anvil handle the tricky parts, like user authentication, email, and version control. When you're ready, deploy your app to the cloud with only 2 clicks. So check out the link in the description to get started with Anvil today. So back in our code, we will accelerate the speed of the enemy vehicle, first by creating a speed variable and assigning it to 1. Then inside the game loop, instead of increasing the y value of the enemy vehicle by 1, we will increase it by speed. Additionally, we will create a new variable called counter right before we start looping, and we will set it to 0. And then in the very first line of our while loop, we will increase counter by 1. Then we can go ahead and evaluate it with if counter equals 1024, which is the amount of iterations that's supposed to pass before we go level up. To do this, we will first increase the speed. So speed plus equals 0.25. Then we will also bring the counter back to 0. And lastly, we would also like to print some kind of a statement inside the terminal. So let's print level up. And let's also print the speed right over there, which makes a lot of sense. So cool, now let's save everything and let's give it a run. And this time our terminal is just slightly larger than usual. We would like to see the print statements of the level up, so let's go ahead and play this game. Okay, level up already. Okay, so it's a bit too fast, but just for the sake of the demonstration, it works. So back in the code, let's do the following. Let's adjust it to 5,000 instead of 1,024. And we will also adjust the speed increase to 0.15 instead of 25. And now, if we rerun our application, it should be perfect. It should be playable, because before it was too difficult. Now, thank you guys so much for watching. I really hope you enjoyed this tutorial. And if you did, please share it with the world. If you'd like to be extra awesome, you can always leave me a like, you can leave me a comment, subscribe to my channel, and turn on the notification bell. I'll see you guys very soon in a brand new NumPy tutorial. So, bye-bye for now!